Hello and welcome to Ott in Math. In this edition of Ott in Math, we're going to work on some problems that involve the theorems we learned in proving lines are parallel. I believe that there are two problems, so let's get started. First one, number 26, we're going to find the values of x, the nearest tenth, that will allow you to prove that m is parallel to line n. So we recall that if we had two corresponding angles that are congruent, then it's going to prove that the lines m and n are parallel. So what we're going to do is we're going to set x squared plus 10 equal to 3x plus 17. And we're going to find the values of x that make these two angles congruent. Okay, so let's go through the process. We say if line m is parallel to n, then we know that 3x plus 17 is equal to x squared plus 10. And if we, in the quadratic, set it equal to 0 to solve for x, then we get x squared minus 3x minus 7 is equal to 0. And now we're going to use a quadratic formula in order to figure out the values of x that make, I guess, y in this case equal to 0, or make the quadratic equation true. So if you recall correctly, it's minus b, quadratic formula, minus b plus or minus the square root of b squared minus 4ac, all over 2a, where the a, b, and c values are relative to the quadratic in standard form. And if you forgot, it's ax squared, the standard form, ax squared plus bx plus c. So our a values are 1, b value is negative 3, and c value is going to be negative 7. So here we have minus 3 plus or minus the square root of b squared, or 3 squared, 9, plus 4 times 1 times negative 7. So that's 9 plus 28, square root of 9 plus 28, over 2a, which is 2. So now I have 3 plus or minus the square root of 36, which is just 6. And this should be so 3 plus or minus the square root of 37, which is approximately 6. So the square root of 36 is 6. 3 plus or minus the square root of 37, or let's just say 36 for our purposes, over 2. And we end up with x is approximately, so let's just say x is going to be, and we write these approximately 4.5 and negative 1.5. Okay, in the next problem we have a coordinate proof, number 27. We're going to use a coordinate proof to prove that the quadrilateral determined by the midpoints of PQRS, so these midpoints, and I draw the quadrilateral, which is now a red figure, of PQRS is a parallelogram. All right, so what I want to do in the parallelogram, I know that opposite sides are going to be parallel. So I want to prove that TU is parallel to WV, as I defined, and TW is parallel to UV. I do that by showing that the slopes of those opposite sides are parallel using, our slopes are congruent, or the same, by using the slope formula. And notice that I am using variables here. I'm not using actual values. Because in the coordinate proof, we want to prove that it's always true, not just in the case when we have particular values. So here we have, I figure out the slope of TU is going to be 2b minus b over a minus 0. So I have b over a. And the slope of WV is going to be b minus 0 over 2a minus a, which is also b over a. So the slopes of TU and WV, so here we have the slopes of TU and WV are going to be the same. So I know that TU and WV are parallel. Now we figure out the slope of TW, and the slope of TW is going to be minus b over a. And the slope of VU is also going to be minus b over a. So I know that TW and UV are also going to be parallel because they have the same slopes. So I've just proved, using the coordinate proof, that the quadrilateral determined by the midpoints of a parallelogram, TU, V, W, are also going to be, they're also going to be a parallelogram. So I've used a coordinate proof to determine that the quadrilateral determined by the midpoints of PQRS is going to be a parallelogram.